Okay, this tutorial is going to review the data gathering and fieldwork methods associated with pedestrian and traffic surveys. We're going to consider these as both a joint surveying technique, but they can actually be independent techniques depending on the context of the study. Pedestrian surveys, for example, are more often than not conducted in retail environments because they are best suited to look at flows across an area which might influence the types of retail where they locate. And it's certainly in retail environments where the number of passing customers on a street could influence the success or failure of a business, then the pedestrian flow is going to be particularly vital. Traffic surveys, which often employ the same data gathering techniques as pedestrian surveys, are more often than not conducted in order to find out either the impact of traffics or traffic changes across an area or traffic changes across a period of time, whether that be a week or a prolonged period of time, especially if you've got baseline data gathered from one point in time and then you're comparing traffic changes, maybe because a road has been built recently or repaired or roads have closed, and you're looking at the impact that that is having on traffic flows across an area. Now, in terms of how data is gathered for both of these, it can either be gathered along a transect, maybe, for example, from a city centre to the edge of a city to see how pedestrian or traffic volumes vary along that transect. That type of technique might suit either systematic or stratified sampling methods to select the actual data points where you're going to gather the data. Of course, choosing the route that you're going to travel along would have to be a route that contains both pavement space to do the pedestrian surveys as well as traffic. So roads would be required, and they would be why stratified sampling might be required in order ensuring that you actually are at the relevant locations and that you have some flexibility about choosing your locations. That's specifically true when health and safety might be an issue in relatively dangerous high traffic environments. In terms of gathering data across an area, which might also suit both of these studies, instead of looking at change along a line, you'd be looking to look at variations of flows across a space. And depending on how you gather data will influence then how you're going to be able to present that data, the choices you can make, as well as any potential analysis. Now, both of these techniques gather what's known as interval data. So that is data which is a direct measurement of something, starting at zero and then counting up, which means that doing a Pearson's test, if you're looking for a relationship between the two to see if one influences the other, would fit this particular type of data gathering technique. Both of them can be time-sensitive data because they are flows. So data can be gathered across a period of time, and that would possibly suit, as we can see here, a radar graph. And you can see how flows might vary both by time of day, but also by day of the week, because we can see the different lines are represented by different colors on this radar graph. And the analysis is shown there. If you're looking to look at how flows might vary if you've gathered your data across an area, then a flow map or a proportional flow line map, as we can see here, might be a useful way of representing your data. And we can see the thicker lines represent higher flows, but we can also see the flow. It's a flow because it's a volume across a space. Pedestrian surveys can also be combined with other types of surveys where you might ask some basic survey questions of your pedestrians passing, for example, on a high street, which might then allow you to plot the sphere of influence. So you could visit, for example, multiple retail environments, asking where customers have come from, and looking at the different spheres that each retail outlet has. So, for example, a large shopping centre, as we can see here, would have a very large sphere of influence because it's a large retail unit, whereas a very small retail outlet like a corner store would have a relatively small sphere of influence because its customers are coming only from the local area. And this data can be represented as shown here with a sphere of influence map. So there's multiple opportunities. One of the key things to think about in this particular technique, both of these techniques, is actually data gathering techniques, because there's a range of ways that you can actually record and measure data, from very simple counts done on a road or on a pavement of the flow as people pass, and that's outlined here. And you can simply use a simple tally system on a chart across a period of time, or if you've got slightly better equipment, you can use a clicker counter, which is slightly more accurate because you can keep your eyes on the moving vehicles or people. Now, the period of time in which you conduct this study is also vital, because if you're comparing flows across an area, then you clearly need to gather data at the same time. Because one of the aspects of pedestrian and traffic data is that it is highly time dependent, and it does vary across time and day of the week. And therefore, your methodology has to account for those variations. If you want to get highly accurate data, then you might go a little bit further and start employing some technology like strips placed across roads or pavements, or entrances to supermarkets, for example, which will record people or cars traveling across them. Now, clearly, that would be desirable because that data could be recorded across a day or a week or even a longer period of time, and it would actually show you the changes across the day and between days. But the downside is that type of equipment requires a degree of technological skill, and both in deploying the equipment, it requires quite a high level of consent from local authorities or whoever's managing the space which you're placing it. And it's also clearly expensive to obtain and use. So for a simple geographic process, it's not possible. If you're looking to overcome the issue of time, then you might want to work in larger groups across an area where data is gathered maybe for 10, 15 minutes at an identical period of time by the whole group, which will allow you to effectively get a point in time data recording.